Hello students, how are you? I hope you are doing good. Okay, so here we are with the question discussion for AIT 4 NEET examination. Okay, so I have selected some problems in which I thought you might be having some problem. Okay, so we are going to solve them one by one. Okay, with the conceptual understanding. Okay, so without wasting so much of time, let's get started. So here is the very first question in your screen. So the displacement time graph of a moving particle is as shown in figure. The instantaneous velocity of the particle is negative at the point. So in this question, we would know what is the formula for instantaneous velocity. Instantaneous velocity is nothing but dx upon dt. Okay. And in displacement time graph, let me write the solution of it. In displacement time graph, the slope of this displacement time graph, slope of dt graph, what is equals to the velocity. And what kind of velocity? The instantaneous velocity. Instantaneous velocity. Okay. So if the slope is positive at a particular point, then the velocity is also positive. If the slope is negative, then the velocity is also negative. So you can see in this graph, let me draw it here. This graph is moved like this. Okay? This is D and this is T. Now at the point C, the slope is somehow positive because it is an acute angle making with the horizontal axis. Okay. At point D, if I draw the tangent, so this tangent having zero slope because it is making zero angle with this. Okay. Now what about point E? Point E has a tangent like this, okay, which is subtending a obtuse angle, which is greater than 90 degree. Okay. So this point have the negative slope. Okay. So point E here, point E making an angle greater than 90 degree. So this point, so E has negative slope. So if E has negative slope and slope is directly representing the instantaneous velocity. So this point E, at point E, we have the negative value of instantaneous velocity. So the correct option here is point E. Option is D, but the answer is point E. Okay, I hope you got this. Okay, move on to the next question here. Body A is thrown up vertically from the ground with a velocity v0, and another body B is simultaneously dropped from a height h. They meet at a height h by 2 if v0 is equals to. So, to solve this question, what do we need? We need to draw a reference point from where this body A is thrown upward. This is the body A thrown upward with a velocity v0. And at some height h, let's say this is the height h, capital H, a body B is dropped. So, solution. We have taken all the direction, all the measurement in the downward direction would be considered as negative, and all the measurement in the upward direction, consider as positive. It is the first thing that you should start with, the sign convention. Okay. Now, this pole B is just dropped. So when a body is dropped, so it has a zero velocity, zero initial velocity. So for body B, for body B, the U initial, or let's say V initial, is equals to 0 because it is dropped. Okay, got it. Now, what does the question say? They meet at a height h by 2. So this ball B has also covered h by 2 here. It is here, h by 2. And this V node has also moved h by 2. So this distance is h by 2. Okay. Now, both the balls has covered same distance. Okay. Now, we have to find out the value of V node. Got it? So firstly, we will apply the second equation of motion, which is S is equals to ut plus half at square. And we are going to apply this for body B. So SB, which is also equals to distance traveled by ball B, which is all equals to minus h by 2. Why minus? Because it has covered the distances negative direction, in downward direction, and downward direction measurement is considered as negative 1. So minus h by 2 is equals to initial velocity u is 0 here. So it is 0 multiplied with t plus 1 by 2 times. There is a gravitational acceleration g which is acting downward. So would be considered as the negative 1 g t square. Okay. Now from here you can say this minus h by 2 equals to 1 by 2 times minus of g t square. This minus and minus got cancel out. 2 and 2 got cancel out. So we have a value of t as square root of h by g. Now we got the value of time. Just find the value of v naught. So for body A, we are going to apply the same equation. S is equals to ut plus 1 by 2 times a t square. What is the value of S for ball A? It is plus h by 2 because it has covered in upward direction. Okay. So it is plus h by 2 equals to u times t. What is the velocity of this ball initially? It is given as v naught. V naught multiplied with time plus 1 by 2 times a would be considered minus g because it is acting in downward direction to t square. Now, if you put the value of time here, so this is h by 2 v naught square root of h by g plus, sorry, this plus and minus got minus, plus minus minus, 1 by 2 times g into t square. If you square this term, time equals to h by g. So it is h by g. Okay. G and g got cancelled out. So here you have minus h by 2. Here you have plus h by 2. Take this minus h by 2 in LHS. So it will become plus h by 2. Okay. H by 2 plus h by 2 become h. So you have v naught square root of h by g equals to h. Now, this h you can also write as root h into root h. So 1 of root h has been cancelled out. So this velocity will become root of gh. Okay. Got it. I hope you are clear with this. So the option B here is the correct option. Okay. Now move on to the next question. In a lift moving up with an acceleration of 5 meters per second square, a ball is dropped from a height of 1.25 meter inside the elevator. So this point has to be noted, inside the elevator. the time taken by the ball to reach the floor of the lift as observed by a person inside the lift. Okay. So this question is from the relative motion. Okay. So this is the elevator. This is the person who is observing the motion of a ball. This is the ball we have. Okay. And it is dropped from a, it is dropped. Okay. Dropped from a height of 1.25 meter. And this lift is moving. Acceleration of lift is 5 meter. Let me just write it here. Acceleration of lift is 5 meter per second square, and there is an acceleration of gravitation which is g. Okay, so here we have to observe the motion with respect to lift, because actually we have to observe the motion with respect to this observer, because this observer is inside the lift. So we are going to observe this motion with respect to lift. Okay, so here firstly we would have to find, firstly we would have to find what is the effective acceleration that is acting on the ball. Okay, now a effective, we have to calculate. This ball is inside the lift. Okay, and while it is moving downward, it is encountering the gravitational pull. Okay, and this lift is moving up with an acceleration of 5 meter per second. Okay, so here we have, if I am inside the lift, okay, so this is the same case when two vehicles, let's say this is vehicle 1 and this is vehicle 2, and they are moving towards each other. And if you are sitting on this, this vehicle B appears to you moving at a much faster rate, because here this is A, so the velocity of B with respect to A would become velocity of B plus velocity of A, because these are moving opposite to each other. So same case for the acceleration. Acceleration of B with respect to A is acceleration of B plus acceleration of A. Okay. So in this case of elevator, you will see this ball has a gravitational pull in the downward direction, which is Z, and this lift is moving upward. Okay, so these are opposite in directions, and we are observing the motion of ball with respect to lift. So here the acceleration of lift is added with the acceleration of gravity, because these are the relative acceleration. Okay, and in the opposite direction, so this would be the effective acceleration. Got it? So acceleration effective, or you can also write it as acceleration of ball with respect to lift. So this is acceleration of ball plus acceleration of lift, because they are moving opposite to each other. So the acceleration of lift is 5, acceleration of gravity is 10. So it will become 5 plus 10 is 15 meter per second. Okay, square. Got it? Now we have to calculate the time taken by the ball to reach the floor of the lift as observed by a person inside the lift. So we have a value of distance that the ball would cover. It is 1.25 meter. So we can apply this second law, second equation of motion, which is S is equals to ut plus 1 by 2 at square. But for here, this distance is 1.25 meter. 1.25 meter is equals to, this ball is just dropped. So the initial velocity of the ball would be 0 plus 1 by 2 times. I have considered the negative direction, downward direction as positive and upward direction as negative. So that is why the acceleration, effective acceleration acting on the ball act in the downward direction. So I have considered positive, which is A effective, okay, into T square. And that is why this 1.25 is also come as positive one. So 1.25 equals to 1 by 2 multiplied with 15 times t square. If you multiply with this, now this is the simple mathematics is there. So this 15t square is equals to what? 2.5. Okay. So the t square here is 2.5 divided by 15. Okay. Which is like 3 5s are 15. Oh, sorry. 5 3s are 15 and 5 5s are 25. So it is 0.5 by 3. Also, you can say it like t square is equals to 5 by 30, 1 by 6. So if you take the square root of it, it will give you a value of 0.4 second. Okay, got it? So this is the correct option of this. Okay, now move on to the next question. A particle is projected with a velocity v so that its horizontal range is twice the greatest height attained. The horizontal range is, we have to calculate. So in this question, this is the question from the projectile motion. Now, how to solve this question? So in this question, it is given that this horizontal range is twice the greatest height. Okay? Means this r here is twice of h. And we know that formula for horizontal range in projectile motion is u square sine 2 theta divided by g. And for maximum height, it is u square sine square theta by 2g. Got it? Put this value in this equation. Okay. So it is u square sine 2 theta by g equals to u square sine square theta by 2g. This g and g would cancel out. U square and u square got cancel out. You have left with sine 2 theta. Sine 2 theta is nothing but 2 sine theta into cos theta. Okay, the trigonometric formula. So if I expand this, 2 sine theta cos theta equals to sine square theta. One sine would get cancelled out. Okay, so here we are with cos theta sine theta. 2 cos theta equals to sine theta. So here we are, tan theta is equals to 2. Okay, so in a triangle, if tan theta is equals to 2, this will be 2, the perpendicular by base. So this would be definitely equals to root of 5 according to the Pythagoras theorem. Okay. Now the range has been asked. So the range here is r is equals to u square sine 2 theta by g. Expand the sine 2 theta. R is equals to u square 2 sine theta cos theta by g. Put the value of sine theta and cos theta. So it is u square 2u square. Sine theta is nothing but, what is the value of sine theta from this triangle? It is perpendicular over hypotenuse. And what is the value of cos theta? It is base over hypotenuse. So put this value here, 2 by root 5 into 1 by root 5 divided by g. Okay. If you multiply this, this will result in r is equals to 4 v square. This is 4 v square by 5g. Okay, got it? So 4v square by 5g option is the correct option. Okay, I hope you got this. Move on to the next question. A particle moves with a constant speed v along a circular path of a constant radius and completes the circle in time t. The centripetal acceleration of the particle can be expressed by. Okay. So this is the question from circular motion. This is the circle we have. Okay. Let's say the radius of this circle is, capital R or small r. Okay. So a particle, let's say here is a particle which is moving with a velocity v, and it is a constant one. Okay. Constant speed. Constant speed means there is no tangential acceleration. The only acceleration present here is the centripetal acceleration, which is acting towards the center. Okay. So this is the direction of centripetal acceleration. In circular motion, centripetal acceleration always acts towards the center of the circle. Okay. So in one revolution, how much distance it would cover? This circumference of this circle. So we can write that this speed is equals to distance upon time. How is the distance traveled? Distance traveled is 2 pi r divided by time t, because it is given that it completes this circle in time capital T. So I have write it here. This is equation number 1. Now, what is the formula for centripetal acceleration? It is v square by r. Or if the angular velocity is given, it is written as r omega square. But here we are interested in v square by r. So we will take it further. V square by r. Put the value of v from equation number 1. So it is 1 by r into 2 pi r divided by capital time t square of it. So 1 upon r, 4 pi square r square by time square. This r would cancel out the 1 of the power of this r. So the final expression for centripetal acceleration that we got with is 4 pi square r divided by t square. But in the option, the term v is present. So we have to modify this expression in terms of velocity. We know that velocity or the speed given here is 2 pi r upon t. We can make the 2 pi r here. It is 2 times 2 pi r divided by t square. Okay. This is the value that we have. Got it? So here it is nothing but this 2 pi r by, we can write it as t. So 1 of the power came here. So it is 2 pi r t square completely. This 2 pi r by t is nothing but velocity. It is speed or velocity, you can say. So here you're got with acceleration is equals to 2 pi v by capital T. So this is the expression for the centripetal acceleration. Okay. So option A is correct. It is 2 pi v by t. Okay. I hope you got this. Move on to the next question. Yeah. So here in this question, what is given? There is a cyclist start from the center O of a circular park of radius 1 kilometer, reaches the edge P of the park, and then cycles along the circumference in anti-clockwise direction and returns to the center along QO. As a result, in the figure, if the round trip takes 10 minutes, the net displacement and average speed of the cyclist, we have to find out. So firstly, what is given to us? What is given to us? Time taken. Time taken is given to us, which is 10 minutes. Okay. So just try to convert the unit initially so that in the later on you will not find the problem, or you do not have to rush about. Okay. So it is 10 minutes. Here the speed is asked in kilometer per hour. So I have to convert this in hour. So 10 minutes is 1 by 6th of hour, because we have 60 minutes. Okay. So 10 minutes divided by 60, it is 1 by 6. Okay. Just a second. Yeah. So it is 1 by 6. Got it? 1 by 6 r. Now, if I draw the path of the cyclist, it is nothing but this is point O here. Okay? It moves along this OP line. Then what does it say? The cycles along the circumference in anti-clockwise direction, means it have to move in this direction, this way. Here it reaches the point Q and then it moves along point Q. So this is the path of it. Okay. And the time cover to cover this round trip is 1 by 6 r. Okay. So firstly, what we are going to do, we are trying to calculate the net displacement or the displacement. Displacement is nothing but final position minus initial position. Now, from where the cyclist has started its motion? From point O. Okay. And where it finishes it? At point O. So the final position and initial position are same. So the net displacement is 0 here. 0. Okay. So the displacement here is 0 because final and initial position are same. Here you can write that x initial is equals to x final. Okay. Now we have to find out the average speed. Now what is average speed? Average speed is equals to total distance traveled, total distance traveled divided by total time taken. Now, what is the total distance traveled? If I calculate the total distance, it is equals to OP plus PQ plus QO. OP and QO is nothing but the radius of this circular park. And radius of this circular park is given as 1 kilometer. So total distance here is 1 plus 1 plus this PQ. PQ, if you would see carefully, it is the 1 by 4th of this circle. This part is 1, 2, 3, and 4. So this part is this curve line. This PQ line is 1 by 4th of the circumference. And the total circumference is nothing but 2 pi radius of the curve. Radius is given as 1 kilometer divided by 4. Because this PQ is 1 by 4th of circumference. Okay, got it? So it is 2 and 2 to the 4. We have pi by 2 plus 2. So total distance here is pi plus 4 divided by 2. I have taken the 2 as the LCM. Okay. Now put this value here. It is pi plus 4 by 2. And we have total time taken as 1 by 6. So it is 1 multiplied by 6. It goes up. So it is 2 3 is 6. So we have 3 times pi plus 4, which is equals to approximately 21.4. If you put the value of pi here, which is 3.14. Okay. Meter per second. So option D here is the correct one. We have 0 displacement and 21.4 is the average speed, not the velocity. It is average speed. And what about the average velocity? So average velocity is equals to 0 because it is the total displacement by total time. So total displacement here is 0. So that is why average velocity is 0. I hope you are clear with this. Move on to the next question. Now, a water fountain on the ground sprinkle water all around it so as to cover the maximum area. If the speed of the water coming out of the fountain is v, the total area around the fountain that gets wet. So here you have the fountain, like say this is the fountain which sprinkles the water. Okay? It has an angle of theta on which it is tilted. So it would cover this area. And if you see it from the top, it would see you as a circle. This is the point where our fountain is, and this is the radius. Okay? And this would be area. Okay, this is the top view. Okay. Now we have to cover the maximum area. We have to cover the maximum area. So what should be the concept? This fountain, if I set this fountain at some angle for which it sprinkle the water for the maximum range, for the maximum range, this range is maximum. So the area covered by it would also be maximum. So we have to find out the maximum range covered by this fountain. So solution of this question is R max we have to find out. R max we have to find out. What is the formula for range? It is the projectile motion. I have told you earlier. It is u square sine 2 theta by g. For theta is equals to 45, we have the maximum range. Okay. So put this here. So R max we have as u square. The velocity is given here is v. So we would take it as v square by g. This is the question number 1. Now, what is the area covered by this? This range would behave for this as the radius. So if I cover this with the maximum radius, so area would be maximum. So area maximum is equals to pi r square maximum, the area of the circle. So this is pi. What is the value of r? It is v square by g. And we take the square of it. So it will become v raised to the power 4 by g square. So it is pi v raised to the power 4 by g square. Okay. So this is the maximum area that the fountain would cover. So the option A is correct here. Okay. Now, on to this question. It is also a kind of relative velocity question. Rain man problem type. Okay. So here the rain is falling vertically downward. This is the rain. Velocity of rain is given as, or the speed is given as, we will say 4 kilometer per hour. Okay. And a girl moves toward the east direction on a straight road. Let's say these are the direction: east, west, north, and south. So the girl is moving in this direction. I would like to write it here. This is the velocity of, speed of girl is given as 3 kilometer per hour. Okay. Now the magnitude of the velocity of rain with respect to girl. We have to find out the only the magnitude. So here you will see these vectors, if you consider them as a vector, these vectors are perpendicular to each other. Vg and Vr are at right angle. Right angle. So the magnitude of vector A, if this is vector A, this is vector B. So what is the magnitude if the angle between them is 90 degree? So the magnitude is simple, A square. square of the magnitude of vector A plus square of the magnitude of vector B. So it is R is equals to root of A square plus B square. So it is a very simple kind of question. So the speed of rain with respect to girl is nothing but the magnitude of it is nothing but square root of speed of girl ka square plus speed of rain square. So it is, we have the values. It is 4, for girl it is 3 square plus 4 square, which gives you square root of 25 equals to 5 meter per second. Although, if you, this is the velocity of rain and this is the velocity of girl, so the vector are free to rotate in space. So I have taken this Vg here, and if you try to draw the resultant, it would be in this direction. So this is the velocity of rain with respect to girl. Okay, and it has a magnitude of 5 meter per second. So option C is the correct option. Now, here this question is also from the relative velocity. Okay, because the relative velocity is kind of tricky and complex topic. Okay, I found it for each of the student, like every student, not everyone, but most of the student would suffer in this topic. So here the situation is given that a police van moving with a speed of V0. This is the police van. This is the police van moving with a speed of V0. On the road, fires a bullet at the thief's car, speeding away in the same direction with a speed of 6 V0. So this is the thief's car. Always the thieves moves faster than the police. So this moving with 6 V0. Okay. Now, what happens? The police fires a bullet at thief's car. Okay. And if the muzzle speed of the bullet is 20 V0 kilometer per hour, like this is the gun that we have, and it fires a bullet of 20 V0 meter per second, kilometer per hour, so kilometer per hour. Now, then the speed of the bullet by which it hits the thief's car. Look, this 20 V0 is given here because this gun is inside the police car or outside, you can say, but it is moving with police car. Okay. So this 20 V0 is the velocity of bullet with respect to police. So velocity of bullet with respect to police given you is 20 times V0. Velocity of police with respect to ground given you as V0, and velocity of thief with respect to ground you have to given as 6 V0. Okay. Now, what is the speed of the bullet by which it hits the thief's car? Okay. So we have to find out the velocity of bullet with respect to thief, that we have to calculate. And it is nothing but velocity of bullet minus velocity of thief. So we have to find out the velocity of bullet with respect to ground. This is our equation 1. So from this equation, from the very first information, velocity of bullet with respect to police is velocity of bullet minus velocity of police. I have taken minus because they are moving in same direction. So velocity of police is nothing but this is 20 V0, velocity of bullet with respect to police. Velocity of bullet we have to find out. What is the velocity of police? It is V0. So from here you can say that velocity of bullet is 21 times of velocity of V0. So this is the velocity of bullet with respect to ground. Now put this value in equation number 1. So you will have velocity of bullet with respect to Thave is velocity of bullet, which is 21 times of V naught minus velocity of Thave, which is 6 V naught. So velocity of bullet with respect to Thave is 15 times of V naught. So this is the final answer to this question. The option A is the correct option. Okay. Now move on to the next question. Yeah. The next question says that a body executing a circular motion has at any instant its velocity vector and its acceleration vector along the same direction, can be anything, in opposite direction, and normal to each other. So we would analyze this. Okay, this is the question of your analogy. So solution of this question we would write here. Now this is the circle. Okay, this is the center of the circle. And if a particle is moving in this direction with a velocity, okay, and it has an acceleration. Centripetal acceleration always acts towards the normal. So from this you can say these vectors are perpendicular to each other. So you can be uh, taking the option D, normal to each other. But this is the incorrect. And that is how the silly mistake is going. Will happen. Okay. So here nothing is mentioned that this circular motion is constant or not constant. It is nothing mentioned in this question. So you have to consider all the scenarios. Okay. So the very big scenario that can happen, that this circular motion is not the constant one, or not is it is not the uniform circular motion. So if it is the non-uniform circular motion, then we have another acceleration which is termed as AT, which is along the velocity vector. Okay. Now, if you calculate the resultant acceleration vector here, so this AC, here we have AC, okay, and this is the tangential acceleration, which are perpendicular to each other. You can see in this question, these are perpendicular to this, because any tangent drawn to the circle will be perpendicular to the radius. Okay. So these are perpendicular to each other. So they have a resultant vector in somehow this direction. This is the A resultant. So we have a resultant vector in somehow this direction, which is not parallel to V, normal to V. So this is a relative acceleration resultant. So what is this angle? This angle can be anything, but from the information of this question, these are not in opposite direction. So this option will not correct. These are not along the same direction, because this is the velocity vector you have got, and this is the acceleration you have got. Okay, so they are not parallel, so they are not same direction. They are not in opposite direction. So, and one thing more, they are not normal to each other. Okay, so this option would also not correct. So the option remain is C. It can be anything. Okay, so here option C is here. This is can be anything. Okay, I hope you got this. So move on to the next question. Yeah. Now the solution of this question is, we have to do, firstly, what is given in the question? An insect crawls up a hemispherical surface very slowly. The coefficient of friction between the insect and the surface is 1 by 3. Okay. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, then maximum possible value of alpha is given by. Okay. So this is the hemispherical surface that I have. It's a center. This is the line that is joining it, and it is making an angle alpha. Okay. Here is the insect. Suppose the insect has mass m. Okay, so this mass m, the line of force would acting downward is mg. Okay, now this mg would have a component in this direction also and in this direction also. If this angle is alpha, if this angle is alpha, what about this angle? This angle is also alpha. Okay, this is the angle from the vertical. This is the vertical, and the same line is there. So this angle would also be alpha. So the component along this direction would be mg cos alpha, and this is mg sin alpha. Now, another force acting on this is the normal force, which is act along the perpendicular to the surface. And if I draw the perpendicular to this hemispherical surface, this would be a line joining to the center. Okay. Now, if we would say this surface is rough, which has a value of mu is 1 by 3. So this mg sin alpha is trying to pull this insect in downward direction. So the friction would act along the upper direction because it opposes the relative motion. This is the value of friction, F. Okay. So from here, you can say that if I balance this force, N is equals to mg cos alpha. Now, if the insect is not moving, suppose this mg sin alpha, because if it is moving upward, this alpha would increase. And if alpha would increase, this increase the value of sin alpha. So this downward force increases, but this friction has a limited value as the limiting friction. We have the limiting friction value. Okay. So this limiting friction cannot go exceed to its value, but this mg sin alpha can exceed because alpha is increasing here. Okay. So what we can say, if this friction force, friction to the surface, is greater than or equals to mg sin alpha. Okay. Now, if the alpha would increase, it will increase this value. Okay. So maximum alpha can be the limiting one, because after that, if this term would reaches the equals to limiting friction, okay, after that, if you increase the alpha, the insect would not crawl because this mg sin alpha would be able enough to pull this insect downward. Okay, because there is no sufficient friction to support this. So the maximum value the friction can have is the limiting one. So we can, which is exactly equals to mg sin alpha at this point. Okay. What is limiting friction? So limiting friction is FL here equals to mu times of n. This is the formula. Okay, put this here. This is mu n equals to mg sin alpha. Okay. So mu 1 into, and what is the value of n? It is mg cos alpha equals to mg sin alpha. Mg and mg got cancelled out. You have cos alpha equals to sin alpha. It will be cot alpha equals to 1 by mu. I have taken this mu in this side, LHS, RHS. So it would be equals to 3 because mu has 1 by 3. So 3 goes up. So here we have cot alpha is equals to 3. This is the maximum value of alpha for which the friction can hold this insect at this position. Because after that, if the alpha increases, it would exceed the value of limiting friction and the insect will crawl down. Okay. So the option A is the correct option. Now move on to the next question. Yeah. Similar question, and I hope most of the students found trouble in this types of question when one block is placed on the other. Okay. So in this situation, there's a block given to you having a mass capital M, and this is the block given to you. It's a block of mass small m. And this block capital M is pulled by a force F. This surface has a value of friction as what? The coefficient of static friction between two blocks shown in the figure is mu, and between the table and the ground it is mu by 2. So this is the table and the ground, it is mu is equals to 1 by 2, and between them it is okay. Now, by what maximum acceleration can blocks move together? So in this question, you have to find out, firstly, you will have to find the block with only frictional force, friction force. So firstly, what you will do, you have to find out the block on which only frictional force is acting. So for that, if on that block frictional force is there, so frictional force is a limiting value, Fl. If the value of friction exceeds the limiting one, then this block will not move together. Okay. Only the limiting friction would hold this system together. Okay. So if I try to calculate this, we have to draw the FBD of it. Okay. This is the capital M block. It is moving in this direction. The force F is acting. In opposite to that, ground will exert a reaction force because this is the friction here, which is F1, I say. Now, this surface would also have friction. Now, this is moving in this direction. So this block mass of m, small m, would try to keep it at this place. So it apply a backward pull by this friction. So a friction F also act. This is provided by this small m. Okay. Now, in the small m block, this block is moving in this direction. So friction trying to opposite this, or you will say here the frictional force by this small m block on the capital M block is in this direction. So equal and opposite direction will be okay. Or you will say this block is moving in this direction. So to remain in contact, this block will also have to move in this direction. So this would have a force in this direction, which is the frictional force. Okay. So the only block we have is small m, which has a frictional value of F, force. The only force is F. So the maximum acceleration is decided by this m block. Okay. Because it has the only force F, which is the frictional force. So this force has a maximum value of F limiting, which is mu times n. And what is the normal reaction to this force? What is the normal reaction to this force? To this block, it is n, and the mass of the block is mg. So n here is nothing but small mg. Okay. If I try to apply the Newton's second law here, which is F external equals to mass of the block into acceleration of the block. So this acceleration would be maximum if I put the limiting friction value, because on this block, the only external force is friction. So friction here is mu times of n is equals to mass into mass of the block into the acceleration. Now mu times, what is the value of this? N is equals to mg equals to m into a. M and m got cancelled out. So the maximum acceleration that you can have is mu times g. Okay, got it? So option D is the correct option. Okay. In this type of question, what you firstly do, you will try to find out on which block only friction force is active. On the basis of that, we will decide that this block move together or not. Because the maximum acceleration that a block can have is provided by the limiting value of friction. Okay. So I hope you got this question. Now move on to the next question. This question is from the work energy and power chapter. So here the force is given to you. F is equals to 5 plus 3x. Okay. Acting on a body of mass 20 kg along the x-axis, displaces it from x equals to 2 meter to x is equals to 6 meter. Now the work done by the forces. So we have to find out, we are provided with the limit also, x is equals to 2 meter to x is equals to 6 meter, and the mass of block, mass is given as 20 kg. Okay. Now what is work done? Work done is equals to force into displacement. But here the force is variable. So we would have to take a short displacement. Okay. For which this force act is the constant one. And then we would integrate it. So we have to find out the dw, the small work. Then we would integrate this dw so that we can get the total work. So here the work is integration of dw, which is equals to integration of, what is the value of f? It is f 5 plus 3x into dx. We have the values of limit of this dx, which is x is equals to 2 to x is equals to 6. So 2 to 6 we have. Now it is very simple question. Just try to pull this, put the values. So it is x 2 to 6 plus 3 times integration of x dx. I have write it here. Integration of any constant dx is equals to c times of x. Okay. And integration of x dx, which is x square by 2 plus constant. This constant, arbitrary constant, comes for the indefinite integration because, but here this is the definite integration. We know the exact limit. So there is no need of this arbitrary constant. So this is 3 times x square by 2, limit from 2 to 6. Put this value, 5 times 6 minus 2 plus 3 by 2 into 6 square minus 2 square. So you would have 5 times 6 minus 2 is 4. So 4 into 5 into 4 plus 3 by 2 times 36 minus 4, 32. So it is 16. So 20 plus 48, you have 68 joule. Okay. This is option C is the correct option. I hope you clear with this question. Now move on to the next solution. Yeah. So constant power P is applied to a car starting from rest. And if V is the velocity of car at time t, then so we have to find out the relation between this. We know that power is nothing but work upon time, work done per unit time. So we can write this work done as force into displacement divided by time. So this P is nothing but, if I, yeah, this is F into d by t. Got it? So I can write this power as, what is the value of F? You can say it is mass into acceleration. Got it? And this is d by t. So from here you will say this mass, and what is this acceleration? This acceleration is nothing but velocity by time. Velocity per unit time is the acceleration. Actually, it is a change of velocity, but for the simplification, I have mentioned only v here. So v by t is the acceleration. Now, what is the value of d by t? D by t is also, it is the displacement per unit time, which is also gives you the velocity. So p here is mass into velocity square into time. Okay. So from here you can say this P times T divided by M is V square. So you can say here this V square is directly proportional to T, means V is directly proportional to square root of T. This is the correct option, is option C. Okay, it's a very simple question. Now, this question. A body initially at rest and sliding along a frictionless track from a height h. Just complete a vertical circle of diameter AB is equals to D with a height h is equals to. Okay. So we have to find out this height h to complete this circle. AB is equals to D, which is the diameter of this circle. So this, since this surface is frictionless, so we can apply the law of conservation of energy. Okay. So what is that? This spot I can say 1 and this spot I can say 2. Okay. So energy of total energy of spot 1 is equals to total energy of spot 2. So total energy means kinetic energy plus potential energy of spot 1 and the kinetic energy of spot 2 and the potential energy of spot 2. This is the reference line for the potential energy. Okay. This is the reference line R. Okay. So initially it has zero kinetic energy because it is just moved. A body initially at rest, na? So the kinetic energy initially is zero. What is the potential energy? It moves, it placed as a height h. So it is mgh equals to. Now let's say the velocity here at this point is v, va. So the kinetic energy is 1 by 2 times mass va square. This potential energy becomes zero because it is at the reference line. So U2 will become 0. Now to complete a circle from the circular knowledge, circular motion, we can say to complete a circle from this endpoint, the velocity must be greater than or equals to root 5 of g times radius of the circle. Okay. So this is the formula that you could keep in mind. So to complete this circle, the initial velocity at the bottom end you will give is should be greater than root of 5gr. So mgh is equals to 1 by 2 times. So we have to find out the, because we have to just complete a vertical circle. So we would take the minimum of it. So VA would be equals to root of 5gr. So here you can say it is the square root of VA. So we would put as 5g and r is radius, but here the diameter is given. So we will put as half of the diameter. So from here you can say mg got cancel out. Okay. This height is nothing but 5 times t by 4. So the two concepts that we have used, firstly the concept of conservation of energy and then the minimum velocity for completing a circular rotation. Okay. So option D is the correct option. Okay. Now move on to the next question. Yeah. This is also a question of collision. Okay. So a ball of mass 0.2 kg rests on a vertical post of height 5 meter. A bullet of mass 0.01 kg traveling with a velocity v meter per second in horizontal direction hits the center of the ball. After the collision, the ball and bullet travels independently. The ball hits the ground at a distance of 20 meter and the bullet at a distance of 100 meter from the foot of the post. So the initial velocity v of the bullet is. Okay. So from this figure, you can say, let's say this is the ball standing here. Okay. It has covered this distance 20 meter and the bullet has covered a distance of 100 meter. 100 meter. This is the bullet coming with a speed of v. Okay. And they strike, collision, and then they move independently. So in any collision, the conservation of momentum is there. So you can apply the momentum conservation. First thing is that now this height is 5 meter. Now, what is the time taken by this ball to cover this height h? So there is a simple formula. It is square root of 2h by g. Okay. T is here is square root of 2h by g. What is this height? This height is 5 meter. G would have to taken as 10. So it is 1 second. So 1 second this bullet has taken to cover this going downward at a height of 5 meter. And this ball would also have cover this 5 meter is 1 meter second for 1 second. Okay. So now if I try to calculate the velocity of ball, so I can cover the horizontal velocity because in horizontal direction there is no gravitational acceleration. So velocity of ball I can say distance divided by time. So the distance traveled by the ball is nothing but how much? 20 meter divided by time is 1 second it has taken. So this ball has a velocity of 20 meter per second. Similarly, the velocity of bullet here is 100 meter per second because it has covered 100 meter in 1 second. So the velocity of bullet is also 100 meter per second. I would have to write it here. Velocity of bullet equals to 100 meter per second. Now, and these are the velocities after collision. Okay. So apply the conservation of momentum. So P initial is equals to P final. Okay. What is the initial value of P? So initially this mass of the bullet plus into velocity of the bullet plus this ball has zero velocity. So initial momentum of the ball is 0 equals to final. Final is the mass of bullet into velocity of bullet. Final value. V dash I will say. Okay. These are the V dash of ball and V dash of bullet. Plus mass of ball multiplied with velocity of ball. We have all the data. What is the mass of bullet? It is 0.01 multiplied with V. Initial velocity is V given in this question. This is V. Mass of bullet is again 0.01 multiplied mass of velocity of bullet that we have found out is 100 meter per second plus mass of ball is 0.2 kg and velocity of ball is 20 meter per second. Okay. So we will say that in the next slide, what do we have? 0.01 into V equals to 0.01 multiplied with 100 plus 0.2 multiplied with 20. Okay. So 0.01 V equals to, this would equals to 1 plus 2 to the 4. So it would cover as 4. So we have 5 over 0.01 multiplied with 200 both the side. V is equals to 500 meter per second. The initial velocity of bullet is 500 meter per second. So option D is the correct option. Okay. Now move on to the next slide. This is the important question and we are going to solve it. Okay. So an impulse J is applied on a ring of mass M along a line passing through its center O. Okay. The ring is placed on a rough horizontal surface. The linear velocity of the center of ring once it starts rolling without slipping. Okay. So this is the case we have. Initially, we have imparted a impulse. So initial velocity I would consider the 0 of this ring, and after imparting this impulse, it has some velocity like v. Okay, I can say the velocity is v, and it start rolling. Okay, the linear velocity of the ring we have to find out once it start rolling without slipping. Okay, got it? So what we can do when it start rolling without slipping, so this point has velocity v, and the circular velocity is omega. So at this point, v is equals to r omega, because it is rolling without slipping. So there is no slipping takes place here. So the net velocity of this point would be 0. So v here at point E, at point P, v here is r omega, we can say, and r is the radius of this ring. Now, what do we have? This surface is frictionless. Okay. So what we can do, we can apply the conservation, because at this point P here initially it has 0 velocity, and finally it also has 0 velocity. So we can apply the conservation of angular momentum here. Angular momentum. Okay. So angular momentum is given by L, and initial is equals to L final. So initially, what do we have? We have two formula for angular momentum. L is equals to R vector cross P vector, which is mvr perpendicular. Okay. And L is equals to, for rigid body dynamics, we have I omega. Okay. I is the moment of inertia of the rigid body. So initially, what do we have? We have only this J, and the velocity of the system is 0. So we can apply this mv. Okay. R equals to initial equals to L final. L final, what do we have? Final, about this point, we are conserving the motion. So this is the R perpendicular to it. So we have to find out the moment of inertia about this point. So we can apply the parallel axis theorem. So which is nothing but I center of mass plus mass into distance square. What is the distance? It is R. So mr square into omega. Okay. We can say that J is nothing but change of delta P, and initial velocity is 0, final velocity is V. So we can say that it is mv. So we can put it here, J into R equals to, what is the center of mass of ring? It is half mr square. 1 by 2 mr square plus mr square. Sorry, for ring it is mr square. Okay, into omega. So J into R equals to 2 times of it is 1 by 2. I realize it. For the center of mass of ring, sorry for this. For the center of mass of the ring, the moment of inertia about the center is 1 by 2 mr square. So it is 3 by 2 times mr square into omega. R and R have cancelled out. R omega is equals to V. Okay. So from here you will say that the linear velocity J is equals to 3 by 2 times M R, and omega is remaining, and R omega would become as V. So it is mv. So we can find out the value of V here. V is nothing but 2J by 3. Okay. So we have taken mistake here because the center of mass of the ring is only mr square. So that is why it would come as 2. Okay. So it is nothing but 2mv. That is why it will become V is equals to J upon 2. Okay. So these are the silly mistakes that you will have. Okay. So option B is the correct option here. Okay. Firstly, what do we have? We will equate the velocity at point P, V is equals to R omega, because we have known that it is rolling without slipping. Then we apply the conservation of angular momentum about this point. So these are the calculation that we have made. Okay. Now the position coordinate at a projectile thrown from ground given by y is given you as y is the vertical component of displacement 3t minus 5t square, and x given you as 4t. So we have to find out the horizontal range of the projectile. So horizontal range is given by only this x. Okay. So what we can do when this y becomes 0, because a projectile thrown from cover a path like this, so it would increases the y maximum height up to h, and then it would decrease this. So when this y, this is the value of y, when this y becomes 0 at this point, we have the range. Okay. So we have to put this y as 0. So 0 is equals to 3t for range. So y is equals to 0. So 0 is equals to 3t minus 5t square. From here you can say that 3 minus 5t into t is equals to 0. So you have two values here. T is equals to 0 and t is equals to 3 by 5. This t is equals to 0, saying that at the initial moment of the projectile motion, the vertical height is also 0. So you will see that this projectile is thrown from this origin. So it has y is equals to 0. Okay. And another time is 3 by 5. So put this 3 by 5 in. X is equals to 4t. 4t. 4 times 3 by 5. So it is 4th is a 12 by 5. 5 to the 10 point. Okay. Meter. This is the simple question. Option A is the correct one. You have to keep this in mind. For range, you have to put y coordinate equals to 0. Okay. I hope you are clear with this question. Now, move on to this question. A particle is moving in a circle of radius r is equals to 3 meter with an angular speed 2 radian per second in clockwise direction as given in the diagram. The acceleration in meter per second square of the particle at point P is. So we have to find out the acceleration. Firstly, what do we need to do? This is the circle that we have. Okay. This is the point P we have at an angle of 60 degree. Okay. So we have to find out the acceleration of the particle, and here in the answer it is given in the vector form. So firstly, what do? We have to find out the magnitude of this acceleration. So acceleration, centripetal acceleration is there. Okay. So it is moving with an angular speed of 2 radian per second. So there is no angular acceleration. So this motion is uniform circular motion you would consider. So this, you will see this acceleration, centripetal acceleration is, you can say r omega square. Okay. What is the value of r? R is given you as, r is given as 3 meter. Omega is given as 2 radian per second. So this is r 3 meter into square of 2 is 4. So 12 meter per second square is the magnitude of acceleration that you have. Okay. Now this acceleration is acting in this direction, AC. So if you resolve this is the component in AY direction, and this is the component in X direction. But it is in downward direction, so it would be considered as negative. And this is also in the left side, so it would also consider as a negative one. So you can write this acceleration vector is nothing but ax I cap plus ay j cap. Okay. Ax here is you can say this is the value of AC, okay? And this angle is 60. I must write it here. This is the acceleration. This is the angle 60 degree. So this angle would become 30. Okay, and this is AX, this is AY, and this is AC. So from here, you will resolve it. This AX here is minus of AC cos 30, which is AC की value. What is the value of AC? It is 12 minus 12 cos 30 is root 3 by 2. It is 6, so it is minus 6 root 3. Okay. And what is the value for AY? It is minus of AC sine 30. So it is minus 12 into 1 by 2, which is minus 6 meter per second square. It is also meter per second square. So put this value in AX and AY. So we have minus 6 root 3 I cap minus 6 J cap. This is the value of acceleration. If you take the magnitude of this, you will have the value of 12. Okay. So option B is the correct option. Now, this is the question. Solution of this question we have to do. Yeah. So an infinite number of bricks are placed one over the other as shown in the figure. Each succeeded brick having half the length and breadth of its preceding brick, and the mass of each succeeding brick being 1 by 4 of the preceding one. So take O as the origin of the x coordinate of the cell center and the mass of the system of the bricks. So what do? We take this O as the origin. This is y-axis and this axis is x-axis. Okay. Also, this is the x-axis positive one. So this is the negative x-axis. What is happening here? If I would consider the mass of the initial one, it is mass of the one brick, first brick, it is capital M. What is happening with the mass second brick? It is going 1 by 4. And also the length of the second brick is going to be decreased by 1 by 2. So if this has a length of A, this has a length of A by 2. And the breadth is also, means the breadth is also B2 is B by 2. Now, if I calculate the center of mass of this first brick, so this is a, you can say, a rectangle. So it has a center of mass on the center where the diagonal cuts it. And it is exactly at the half point of this A by 2 and half of the brick. So I have the center of mass of this first brick. Center of mass equals to at A by 2. And the y coordinate of it is B by 2. But we are interested only in the x coordinate of the system. So if the x coordinate of center of mass of first brick is A by 2, now the center of mass of second brick would become, because this length is decreased by half, so we would put A by 2 and by 2. It is the half of the, so it is A by 4 and on and so on. Now what is the formula for center of mass of the system? So x center of mass of the system is equals to mass of m1 x1, which is the first coordinate of center of mass. I am representing it as x1, it as x2, m2 x2 plus m3 x3 plus ups to n, and this is the total mass m total. Okay, so m total here is capital M, you can say. No, you can say this because mass is also constantly decreasing and there are infinite number of bricks are placed. So what do we left with? This is the x of center of mass of the system. Okay, which is m1 x1, m2 x2, m3 x3 plus divided by m1 plus m2 plus m3 plus up to infinite. So mass total we can say is m1 plus m2 plus m3 plus up to infinite. What is the value of mass m? It is capital M. Then it will become 1 by 4. Again, it will become 1 by 4. So it will be 1 by 60. This is going to be infinite term. So if you would see this carefully, this is the GP that you would have. Okay. So this is the GP, which common ratio, if you divide this term by this term, m by 4, m by 4 divided by n, it is 1 by 4 you have. Okay. So sum of infinite GP, sum of infinite GP. What is the formula for that? Sum of infinite GP is A upon first term upon 1 minus common ratio. So here the first term we have as capital M divided by 1 minus. What is the common ratio? It is 1 by 4. So what do we have? 1 minus 1 by 4 is 3 by 4. And we reverse this. So it is 4m by 3. This is the total mass. Now, the upper part, which is, I must say, mx final. So it is m1x1, m2x2, m3x3 up to. So m1x1 is, m1 is m, x1 is what? A plus m2 is m by 4 and x2 is a by 2. It is 16. Then a is a by 4. Infinite. So if I take ma common here, we would have 1 plus 1 by 8 plus 1 by 64 times 4. This would also result in a GP which has a common ratio of 1 by 8. So the sum of this series would be equals to MA into first term, which is 1, 1 minus 1 by 8. It is 7 by 8. So 8 would go up. So it is 8MA over 7. Okay. If I put this value in this expression, what do we have? What do we have? Okay. So we have x of center of mass of the system is equals to, upper part would have come as 8MA by 7 divided by lower part is 4M by 3. So M and M got cancelled out. So this would become 8 by 7 multiplied with 3 by 4. 4 to the 8. So it is 6 by 7. So 6 by 7 times of 8. So the final value of x coordinate of center of mass is 6a by 7, but in negative direction because we have measured the direction in negative one. Okay, got it? So here we are with this question. Okay. So I hope you are clear with this. All the concepts are clear to you. Okay. So these are the questions that I have to discuss with you. I am thinking that you are finding some of the problem here. So yeah, this is it. If you have any kind of doubt, you can reach me out. Okay. Thank you so much for attending the session.